Your heart stops beating. But you don't stop. Not yet. For hours, your body keeps working on a schedule. It cools on a timer, stiffens on a timer. It changes color in a fixed order. Nearly every body runs the same clock. And a trained eye can read it, often to within hours. This is the machine that switches on when you switch off. Start at the beginning. The heart stopping has a name: clinical death. It feels like the end. It isn't. Because your cells don't get the message right away. Each one still holds a small reserve of oxygen. For a few minutes, they keep flickering along. Some tissues hold on for hours. You don't die all at once. You die slowly, cell by cell. The heart is just the first light to go out. One by one, the others follow. The shutdown has quietly begun. The first visible change comes fast. Within roughly 15 to 30 minutes, your skin pales. With no pulse, blood no longer fills the surface. It drains from the tiny capillaries beneath the skin. The color fades. This is called pallor mortis. The living flush of a face is gone. Then a second change starts, invisible and steady. Your body begins to leak its warmth. Under average conditions, it cools very roughly a degree or so an hour. Warm to cool, cooling toward the room around it. This is algor mortis, the cooling. It's one of the first clues investigators read. A thin body in the cold can cool far faster. So the number is a guide, never exact. Temperature, clothing, size, air, everything shifts it. Still, the body drifts toward the room's temperature. Within about a day, they usually match. The warmth that was you is gone. The gravity takes its turn. With no heartbeat, nothing keeps the blood moving. So it obeys the only force left, gravity. It sinks to the lowest points of the body. There it pools and stains the skin. A deep purple red spreads across the underside. This is livor mortis, lividity. Faint patches can appear within 1 to 3 hours. At first the blood can still shift. Press the skin and the color blanches away. Move the body and the stain follows gravity again. But not forever. By roughly 8 to 12 hours, the stain tends to fix. Fixed means it stops moving even if you move the body. And here is the quiet twist. Imagine a body found lying on its back. But the lividity stains the front. The blood settled while the body lay face down. Someone turned it over, hours after death. The marks in the position don't match. That kind of mismatch has helped solve murders. The body keeps a record, even in stillness. Next, the body begins to lock. Muscles need a fuel to release their grip. In life, that fuel is a molecule called ATP. After death, no more of it is made. The supply runs dry, so the muscle fibers seize and cannot let go. This is rigor mortis, the stiffening. The change is happening everywhere at once. But we notice it in the smallest muscles first. The jaw, the eyelids, the fingers. Around 2 to 6 hours in, the stiffening becomes obvious. It shows next in the larger muscles. Near 12 hours, the whole body can be rigid. This is peak stiffness. Then, slowly, it begins to fade. But not because the muscles relax. The tissue itself is starting to break down. As the fibers dissolve, their grip finally loosens. By roughly 1 to 2 days, the stiffness is gone. The body tightens, holds, then quietly releases. And now we reach the part almost no one expects. With the oxygen gone, the cells turn inward. Every cell carries its own tiny tools. Small packets of enzymes meant for cleanup. In life, they are kept carefully contained. In death, the containment fails. The enzymes spill out inside the cell, and they begin dissolving the cell from within. The body starts to break itself down. Scientists call this autolysis, self-digestion. It begins in the very first hours. Silent, invisible from the outside. Remember, none of this is felt. It all happens after death with no awareness. Autolysis is only the opening act, because your body was never truly alone. Your gut is home to trillions of bacteria. In life, your defenses keep them in their place. In death, those defenses switch off. Now nothing holds the bacteria back. They spread out of the gut and through the body. As they consume the tissue, they release gas. Hydrogen sulfide, methane, ammonia. The gas builds inside the abdomen, and the body begins to bloat. This stage is called putrefaction. In temperate conditions, it often shows around 2 to 3 days. As it advances, the skin begins to change. The gas reacts with the blood in the veins. Hemoglobin can turn a dark green-black. It traces the veins like a branching map. Forensic scientists call this pattern marbling, a roadmap of decay drawn across the skin. And there is the smell. It comes from real molecules of decay. 2 of them are named for the dead, putrescine and cadaverine. Strangely, they also turn up in bad breath. The chemistry of decay is closer than we think. All of this follows a known sequence. Decomposition is often split into 5 stages. The first is fresh. The clock has just started. The second is bloat as the gases build. The third is active decay. Here the body loses the most mass. Soft tissues break down and liquefy. The fourth stage is advanced decay. Little soft tissue is left to consume. And the fifth is dry or skeletonized. Bone and little else remains. The same broad stages again and again. But the speed is not fixed. Where a body rests changes everything. Forensic scientists cite a classic rule of thumb. It's known as Casper's dictum. In open air, decay runs fastest. In water, it runs roughly twice as slow. Buried in soil, roughly 8 times slower. 1 to 2 to 8. The same machine, only the pace changes. The body is rarely left alone for long. Within minutes, the first visitors can arrive. Blowflies can find a body almost immediately. Within a day or 2, they can lay their eggs. The eggs hatch into maggots that feed and grow. And their growth is startlingly predictable. Each stage of a maggot takes a fairly known time, so the maggots become a living clock. This field is called forensic entomology. Insects can help date a death over weeks, even months. Each stage of decay leaves a kind of time stamp. Temperature, color, stiffness, insects. But here's the rule that matters most. No single sign is ever trusted alone. Each one shifts with heat, cold, and conditions. So investigators never rely on just one. They combine them and cross-check every clue. They add tools like the Henske nomogram. It weighs body temperature against the conditions found. Together, the signs narrow down a time of death. Not a stopwatch, a careful, layered estimate. And to keep those estimates honest, science needs data. So there are places built for exactly this. They're called body farms. Outdoor facilities where donated bodies decompose. One of the first opened in Knoxville, Tennessee. Researchers study every stage in real conditions. People donate themselves so the estimates stay accurate. Their final gift is a more truthful science. So think back to where we started. Death looks like chaos and collapse. But it isn't chaos at all. It's one of the most orderly processes your body runs. A sequence, a largely predictable machine, and every human body carries it. The clock, the cooling, the settling, the stages. It comes standard. It's already installed. It sits quiet inside you, waiting for a signal. The clock isn't ticking yet, but make no mistake, it's already set.